The experiment requires a raw egg, 2 clear glasses, and ordinary tap water. Common table salt, sodium chloride, is also essential for altering water density. A spoon is needed for mixing salt into the water to create a saline solution. All materials should be neatly arranged on a clean, stable surface for optimal experiment execution. Obtain a clear, transparent glass for filling. Use plain water for the filling process. Pour the water into the glass. Fill the glass to approximately 3/4 of its capacity. A raw egg is gently placed into a glass filled with plain water. Observe that the egg sinks and settles at the bottom of the glass. This indicates that the egg's density is greater than the density of the plain water. Density is defined as mass per unit volume. Objects denser than water will sink, while less dense objects will float. An egg placed in plain water will sink to the bottom. This occurs because the egg's density is greater than that of the water. Density is defined as mass per unit volume. The egg contains more mass packed into the same volume compared to the water. Therefore, the gravitational force acting on the egg is stronger, causing it to sink. A second clear glass is required for this demonstration. This glass will be filled with plain water. Ensure the water is clear and free from any additives. The water level should be similar to that in the first glass. This glass of water will be used to create a salt-water mixture. The salt-water mixture will be compared to the plain water in the first glass. Prepare a glass of water for salt addition. Measure out 3 to 4 spoons of salt. Visually confirm the measured amount of salt. Add the measured salt to the glass of water. Begin by adding salt to the water in a suitable container. Use a spoon to thoroughly mix the salt and water together. Continue stirring until the salt completely dissolves into the water. The water may appear slightly cloudy during the mixing process. Ensure no salt particles remain visible at the bottom of the container. Salt water is created by dissolving salt into water. The process involves the dispersion of salt particles throughout the water. Full dissolution occurs when the salt particles are no longer visible. The resulting solution appears clear, with no solid salt present. This indicates the salt has fully integrated into the water at a molecular level. A raw egg is gently introduced into a glass filled with salt water. The behavior of the egg within the salt water is observed. This experiment demonstrates the principles of buoyancy and density. The egg's movement and position in the water are key indicators. Observations should be carefully recorded to understand the underlying scientific concepts. An egg is placed in a container of salt water. The egg is less dense than the salt water. Buoyant force acting on the egg is greater than the gravitational force. The egg floats, suspended in the salt water. The egg does not sink to the bottom. The egg remains visibly afloat within the liquid. The experiment involves comparing an egg's behavior in plain water versus salt water. 2 glasses are prepared, one with plain water, the other with salt water. An egg is placed in each glass to observe the difference in buoyancy. In plain water, the egg sinks to the bottom due to its higher density. In salt water, the egg floats because the salt increases the water's density. The side-by-side comparison visually demonstrates the effect of density on buoyancy. Density is defined as the amount of mass contained within a unit volume. It is a fundamental property of matter that relates mass and volume. An object's density determines whether it will float or sink in a fluid. Objects with a density less than the fluid they are placed in will float. Conversely, objects denser than the fluid will sink. Density is a fundamental property of matter, defining mass per unit volume. Plain water, or H2O, exhibits a specific density under standard conditions. The density of water is approximately 1 gram per cubic centimeter. 1 gram per cubic centimeter. This density is influenced by temperature and pressure. Water molecules in liquid state are relatively spaced apart, allowing movement. This spacing contributes to water's characteristic density. Egg density is a measure of how much mass is contained within a given volume of an egg. Density is determined by the arrangement and proximity of molecules within a substance. In an egg, the molecules are packed more closely together compared to water. This closer packing results in a higher mass per unit volume for the egg. Therefore, the egg exhibits a greater density than water. Salt water's density is influenced by the presence of dissolved salt particles. These salt particles occupy space between water molecules. The addition of salt increases the mass within the same volume of water. This results in a higher concentration of mass per unit volume. Consequently, salt water exhibits a greater density compared to pure water. The animation visually compares the densities of an egg in different solutions. The first solution is plain water, serving as a control for comparison. The second solution is salt water, which has a higher density than plain water. The animation uses visual cues to indicate the relative density levels of each solution. The egg's behavior in each solution demonstrates the principles of buoyancy and density. An egg sinks in fresh water because its density is greater. Adding salt to water increases the water's density. Salt water is denser than an egg. The denser salt water provides a greater buoyant force. This buoyant force is strong enough to counteract the egg's weight, causing it to float. Buoyant force is the upward force exerted by a fluid that opposes the weight of an immersed object. When an egg is placed in salt water, it experiences buoyant force. The salt water, being denser than the egg, exerts an upward buoyant force on the egg. This buoyant force counteracts the gravitational force pulling the egg downward. If the buoyant force is greater than the egg's weight, the egg floats. An egg sinks in plain water due to its density relative to the water. The egg's density is greater than that of the surrounding plain water. Density differences cause the egg to experience a greater gravitational force. This gravitational force pulls the egg downwards, resulting in its sinking to the bottom. Gravity is a fundamental force that attracts objects with mass towards each other. In this demonstration, an egg is submerged in plain water to visualize gravity's effect. The gravitational force acts on the egg, pulling it downwards. This downward pull is due to the Earth's gravitational field interacting with the egg's mass. The water provides a medium in which the egg's movement due to gravity can be observed. The egg's descent illustrates the constant and universal nature of gravitational attraction. Density plays a crucial role in buoyancy, explaining why some objects float while others sink. Ships float because they are designed to displace a volume of water that weighs more than the ship itself. This displacement creates an upward buoyant force that counteracts the ship's weight, keeping it afloat. Understanding density is essential in various fields, including naval engineering and marine biology. A ship floats due to the principle of buoyancy, which counteracts the ship's weight. The ship's hull is designed to displace a large volume of water. The weight of the water displaced by the ship is equal to the buoyant force acting upwards. When the buoyant force equals the ship's weight, the ship floats. Therefore, a ship floats because it displaces enough water to equal its own weight. Hot air balloons demonstrate a practical application of density principles. The air inside the balloon is heated, reducing its density compared to the surrounding air. This density difference creates buoyancy, causing the balloon to rise. The balloon ascends because the less dense hot air displaces the more dense cooler air. Hot air balloons operate based on the principle of buoyancy. Heating the air inside the balloon reduces its density. Less dense hot air rises when surrounded by denser, cooler air. This difference in density creates lift, causing the balloon to ascend. This experiment demonstrated the principles of density and buoyancy. An egg sinks in fresh water because it is denser than the water. Salt water is denser than fresh water due to the dissolved salt. When salt is added, the density of the water increases. If the salt water becomes denser than the egg will float. Therefore, the egg floats in salt water due to density differences.